Alright, so in the start of chapter 6 we have a conversion which basically changes pi radians equals 180 degrees. So if I want to change 35 degrees into radians, I'm going to multiply it by pi over 180. Now normally we just leave pi in our answer, so if we take 35 divided by 180 and just reduce the fraction, we're going to get 7 pi over 36. And on the opposite way, if we wanted to have pi over 5, and we want to change that into degrees, we multiply by 180 over pi, and the pi's cancel, and so 180 divided by 5 turns out to be 36 degrees. The next thing we talked about was how do we find something like this sine of 11 pi over 6. So I treated this as 1 5/6 pi. So on my unit circle, here's 0, here's 1 pi, here's 1.5 pi, and here's 2 pi. Now because we didn't get quite to 2 pi, my answer is going to be in the fourth quadrant. And the reference angle is going to turn out to be pi over 6, which we know better as 30 degrees. So we have our 30, 60, 90 triangle over here, where across from the 30 is -1, the hypotenuse is 2, and the adjacent is the square root of 3. So the tangent of 11 pi over 6 turns out to be the opposite of -1 over 2. Let's take a look at one more of these. Let's do the cosine of 11 pi over 4, which turns out to be 2 3/4 pi. There's 2 pi, and back around the other way will be 3 pi, so 2 3/4 is right over there. So since we need to have the reference angle between 2 3/4 and 3, that would be pi over 4, which is also known as 45 degrees. X, X, and X square roots of 2, where this is positive on the side and the bottom is negative. So negative x over x square roots of 2 is -1 over the square root of 2. Or you could call it negative square root of 2 over 2 if you rationalize, but if it's free response, I'll take either one of these answers. And that is all for the first part of chapter 6.